All right, students, here's lesson 17 showing that m in y equals mx plus b is the slope and converting standard form to y-intercept form, standard form being ax plus by equals c to y equals mx plus b. So let's take a look. First of all, we're going to prove that m is the slope. And we're going to start with our proportional relationships because it's a little easier. We know this from last year. Proportional relationships start at the origin, 0, 0, and they go in a straight line. Okay? So we're just going to pick our random point here. We're going to call it 1m. That means I started from 0, 0. I went m up, and I went 1 over. How big m is doesn't really matter, but we remember from our second lesson there, our first lesson, that the slope is the change in y. How much did I go up, m, and how much did I go over, the change in x? I went over 1. So the slope here is m over 1. And we can also use our equation for the slope by subtracting y2 minus y1 over x2 minus x1. Just do the same thing. So if y2 is m and y1 is 0, I have m minus 0, and x2 is 1 and y1 is 0. So we have 1 minus 0. M minus 0 is m, 1 minus 0 is 1. So again, we have a slope of m over 1, which is just m. All right. So the slope is m. And this works for any point. So if I pick a random point, and one way we prove things is to pick a point that doesn't have a number and have a letter. So that could be any number. So we're going to call this our x2 and our y2 points. And we're going to go back to this for our x1 and our y1 points, right? And we're going to subtract them. So y2 is just y, and y1 is 0, so y minus 0. And x2 is x, and x1 is 0, so x minus 0. And that becomes y over x. So the slope of this line at any point is y over x. Okay? And if you remember from proportional relationships, y over x is called the unit rate or the constant. And if you remember, the equation for a unit rate, for a direct proportional relationship, is y equals the constant times x. Well, now we know the constant, which is y over x, is also the slope. So we can rewrite this as y equals mx, m being the slope of this line. All right. So that's all fine and dandy for proportional relationships. What happens if we have a non-proportional relationship, but it still has a straight line? So this is the origin down here. So this is not a proportional relationship because it starts at 0b. Okay. So let's find the slope. Remember our slope equation, y2 minus y1 over x2 minus x1. So if this is x1, y1, and this is x2, y2, then our slope is m plus b minus b over 1 minus 0. Well, plus b minus b is 0, so we have m plus 0, or just m, over 1, which is our slope. Right? And we can double check this by saying, The distance from here to here is m. I know that because this point right here is m plus b, and this point right here, from here to here, is b. So I went up b, and this here is m plus b. So if I subtract the b, this part right here from here to here is m. And this distance across is 1. So the slope is m over 1, which is m. So we've got that out of the way. The slope of this line is m. Is the slope at any point still going to be m? So I've got a new point here, and I'm going to call this my new x2, y2, right? And this is still my x1, y1. So I'm going to subtract it. I'm going to do my slope formula again. I'm going to say y minus b over x minus 0 equals m. Okay. Y minus b is still y minus b. X minus 0 is x. So this is y minus b over x equals m. Now I'm going to do some algebra here and just kind of simplify this. So I'm going to multiply both sides times x. So x times y minus b over x. These x's cancel out. So I have y minus b equals m times x. And then I am going to change colors so you can see better. I'm going to add b on both sides. Negative b plus b is 0. So I'm left with a y over here. And I have mx plus b. So this is what we call our slope-intercept form of the equation, of a linear equation. Y equals mx plus b. M is our slope, and b is right here. This point where the line crosses the y-axis, and that is called the y-intercept. So this form of the equation we call the slope-intercept form of a linear equation, because it tells you what the intercept is, where the line crosses the y-axis, and it tells you what the slope is, how fast does the line go up versus how far does it go over. So this is very useful information, right? If I have this point, if I have this equation, y equals 7x minus 3, if minus 3 is my y-intercept, that means the line is going to cross right here at 0, negative 3. And the slope is 7, which is 7 over 1. That means I go up 7, 1, 2, 3, 4, 5, 6, 7, and I go over 1, and that's my line. So I can draw that by drawing the line between 2 points. And that's my line. So this is point 1, 4, because I go over 1 and up 4. And my slope is 7 over 1, and my y-intercept is 0, negative 3. Right. So let's put the other points on this line. So this one is y equals negative 3/4 x minus 3. So I have the same intercept here, but now I have a negative 3/4 of a slope. So I go down 1, 2, 3, and over 1, 2, 3, 4 to this point, which is 4, -6. So this line is, do a solid line, this line. So this line up here is y equals -3/4 x minus 3. And this line was y equals 7x minus 3. How about y equals x minus 3? So let me grab another color. Again, we're starting at 0, -3. But now we have a slope. When there's no number there, that's a slope of 1, which means we go up 1 and over 1 to this point. So this is point 1, -2. So this line is this. And it'll really go on forever, but we'll just draw it right there. So this is the point, the slope of the line y equals x minus 3. And then our last one, y equals 2x minus 3. Again, we're starting at -3, and we're going with a -2 slope. So that means -2 down, 1 over. And that is point 1, -5. So we have 1, -5. And this one is this line here to here. And this line again can go forever and ever and ever. Okay? This line can go forever and ever. That line can go forever and ever. They all go forever and ever. Okay? And that was line y equals -2x minus 3. So each of these lines has a different name. They have a different slope, but they all have the same intercept. So even though they go through the same point, 0, -3, if they have different slopes, they are different lines. All right, moving on. When in the form y equals mx plus b, the slope is m. We prove that if you pick any 2 points and find the change in y over the change in x, you get the slope m. Standard form is ax plus by equals c, and slope intercept form is y equals mx plus b. And one more thing we got here is if they have the same intercept but a different slope, they are different lines.